to look at particular.
Okay, cool. Yeah, so these will be a little bit brief, but they are really good references to go back to if you need. But the example that I want to get through for the last 10 minutes will be helpful. So this is kind of a step-by-step of the GIR for a mapping area in Parkfield, California. So it is along the San Andreas Fault. So there are quite a few indicator features on this. It was done for the magnitude 6.0 earthquake in 2004. And so this imagery that I got from Google Earth was taken prior to the earthquake occurring, because everything we want you guys to do will be before the earthquake occurs. So you guys don't see any of that fresh active fault indicators that would have resulted from the most recent faulting. Yes. All the indicators I can in office hours too. The sheet we're going to give you guys that lists all of them is quite expansive, but it does give descriptions and justifications as to why. Oh, on that slide. Yeah. So the next one, going to show you all the mapped features on this one. So this is it as the satellite imagery, and I'm going to show you the same area on a hillshade from what I did my mapping on. So this is and this one is quite bad, but it's a 30-meter SRTM. And so this is what I did in junction with the Google imagery. I toggled between them back and forth to do the geomorphic mapping. And going back to Alex's point, pretend the fault line's not there now because I did the geomorphic mapping first, but I mapped out the drainages in blue. Any morphologic element I had mapped in purple. So I had ridges in purple. The one at the very bottom is a shutter ridge. And I have at the bottom left a triangular facet. The green is a landslide. The blue circle above it is a sac pond depression. And then I have everything in yellow as anthropogenic alteration. This was a back road that was carved out. So you'll first want to map all of the geomorphology you see. If you want to do it with lines like this and it's a bit clearer for you, or if you just want to start marking out the points and labeling all of the features you see, that's good too. But you want to do the geomorphology first before anything. You might have an idea of where the fault is if there's a really big clear lineation in the surface. But the idea is you can't put the fault or score the fault before you've done all the geomorphic mapping. But once you have finished it and you have the idea of where the fault could be, you can put your trace down along the surface. And then these circles are the 1 kilometer segments. So like, let's say if that landslide went across both segments, you would count it once for the one above and then once for the one below. But it's only constrained into one segment, so you'll count it once. And I have labeled to all of the features that I saw. And so I have the beheaded drainages up here, the depression sac pond, the landslide alteration, and on the other imagery, you could see erosion. So that would be something that I would mark that would take away my confidence from that segment. And all the morphologic elements like ridges that or just upslope convex that we talked about in the Walls Creek assignment can help fortify the location of a fault too, if they're in junction with all these other higher ranking fault features. And erosion is if the feature that you see has a much lower preservation than the features around it. So if the erosion either from water or wind, or it's just a feature that you see is a lot poorer quality than the other ones you're seeing, it's going to lower your confidence that that feature might be accurately identified. Yeah, and so the triangular facet down there too was mapped for a different fault trace. So although I'm mapping it here in the geology, I won't be counting it with this fault trace because it's not a direct result of that fault. The sac pond. could be a small secondary fault. I thought it was a result of that fault trace too. So it will have to be kind of your mapper's intuition whether or not you think that feature is there because of your mapped fault or not. The location of the slag pond to the fault trace, there might be two, yeah. The location can vary too. Sometimes the depression or slag pond can be directly on your fault trace. Sometimes it can be a bit away from it. It just kind of depends on the area. And this is the scale for everything. So that's about 1 kilometer. Or you can use the segment too as 1 kilometer. And so if you finish that, you have your simple fault trace. You're going to start using the GIR point shapefile. So all of the features that I've mapped out as indicators, I'm going to replace now with points. And so when you map them, you will label them of what feature it's referencing, but this is what it'll look like when you're just using the GIR shapefile. And you can see that there are many more points up here as opposed to down here. The features that we did map previous at the top or towards the bottom. And the features that were at the top had a higher scoring as well. So you can sort of get a sense of the strength or your confidence of that fault trace as opposed to the one at the bottom. So when you add all of them up, and I'll show you the next slide, I kind of created the black lines in that image as zones of the features that you want to capture for when you're counting them. And at the bottom, you see like that I had 20 segments in there, but that segment had 3 beheaded drainages, 1 scarp, 1 slag pond, a landslide, 3 elements, and then some anthropogenic alteration. So that gave me a segment score of 16. And I did the rest of the scoring for the other 2 segments, and that gave me a score of 6 and a score of 4. But you won't be doing the scaled score, so you guys will be kind of using your intuition to say, I have a score of 16 right here, and then this other one I have a score of 4. So according to the fault confidence ranking shapefile on the left side that you guys will do to be assigning your confidence to the faults when you're placing them, you'll say that one's probably the strongest when it has the highest score along all the other segments of that trace. So it's going to have a strong, but if you had multiple segments and there's another score of like 13, it would be up to you to say, do I want that to be a weak, or is it still high enough that it has a strong? And there's a lot of high scoring features still in there. And there might be some segments where you don't have any indication of fault. They might just still be along the similar strike of the rest of the trace. And that's when the lowest score can be used, the uncertain and primary. Do we have any questions about this?
I do.
Yes.
And it's kind of more of a general question. Are we going to be able to eventually get to the point where we can use these indicators to also understand relative motion of the 2 faces and understand what type of faulting and orientation it is?
Yeah, so when you map the indicators, each symbology that you do in, you have to put either like SS, N, or R before the feature to indicate whether you think it's a result of strike slip, normal, reverse, like what type of faulting it is. And you may not be able to tell some, like with strike slip, you can tell relative sense of motion with the features, but a lot of it is going to come from experience and then the lectures in class and the reading that we're going to look for more indicators of how you can tell relative motion. But the features sometimes can help with that, but mostly it's up to the mapper's intuition or preliminary information we may give you sometimes about what kind of faulting environment it is.
Mara? You had your
Yeah,
hand.
is there literature on this, or is this something that is strictly for this class, or?
It's strictly for this class. This is kind of a tool that we're testing out to see the effectiveness. There's a lot of literature, and I'll post them in the chat too, of people using geomorphic indicators to try to locate where the map is, or they rank their fault of confidence. But this like specific tool where we're mapping them and counting them and assigning the features a score per se to try and directly correlate to the fault confidence is new. And so we're specific to this class, but there'll hopefully be literature about it if it goes well. But the idea is to try and create it so it's repeatable, because there can be a lot of variation between mappers oftentimes. And so if we have this tool, hopefully it's repeatable enough that the same mapper can use it and get similar results to a different mapper.
The papers that Ramon put in the chat earlier have some quantification of geomorphic indicators. They're slightly different than what we're doing here. So we're essentially building the literature with the work we're doing with this class. Yeah, there were a couple papers that he posted links to earlier that are similar.
Yeah, and a good emphasis that Ramon has been saying as well is that we want to do the geomorphology first and foremost, and then not rely too much on the faulting until the very end. We want to rely on the geomorphic features and vary from first and foremost, and then later comes the faulting, because everything and the placement and the location and certainty should be a result of all of the geomorphic mapping that you've done.
Okay, we're past class by a few minutes. So I think this is Rachel's last slide.
Yeah, it was just a recap again. And I'm gonna post the slideshow directly after class ends, and we'll post the video again. And I know that was a lot of information and it might have not been incredibly clear. So if you do have any questions at all, I still have office hours tomorrow if you have any remaining questions about this or on the Walls Creek assignment too.
Well, and we'll be talking about it again on Thursday.
Mhm.
And then you'll be building these tools starting on the next assignment throughout the semester. So,
Yep. So we just want to introduce it to you guys, and then we'll develop it as it progresses.
And if you guys don't mind bringing your laptops or having QGIS available with you guys on Thursday, we're going to walk everyone through the shape files and make sure everyone can use them and everything's good to go for you guys.
Awesome.
We'll stay on a bit too if anyone has any questions.
Thank you.
Yep, I'll stay on too for a minute.